Welcome to the last talk. Thanks for staying this long, staying with us, staying with this awesome conference. Our talk will be about stop juggling with secrets and using HashiCorp Vault for secret management. So, what we'll present today, I'll give a bit of background, present the challenges that we have faced in terms of secret management and we have seen, then tell you a brief introduction of why for us HashiCorp Vault was the solution that came to the rescue for us, and then Thomas will give you an extended demo of what we are doing with HashiCorp Vault. So first, who we are. My colleague Thomas Störmer, Solution Architect at Schenker AG. I am Tilman Göhnert, DevOps Specialist at Schenker AG. Schenker AG is an international logistics company. We are doing ocean freight, air freight, contract logistics, land transport. And the two of us are in a department of Schenker that is concerned with mostly internal software development. So software that is used within our company. And in the recent years, also for us, we have been moving to the cloud. So we are currently working in projects that are all related with movement to the cloud or already are operated in the cloud. So our infrastructure is in the cloud. The applications that we are currently dealing with are all in a Kubernetes cluster. Yes, we are already running Kubernetes in production. And we do our deployment via CI/CD pipelines. So automated as much as we could. So in this context, what are the challenges for secret management that we have? Challenges are distribution, lifetime, gossips of secrets, and secure storage and handling, the most basic one. To go a bit more into the details of these things, so distribution of secrets means how can we get the secrets into applications? I mean, it's nice that they are somewhere, but we need them in the applications to connect to other services, to connect to databases, for example. We also need to handle infrastructure setup and handle our secrets in there. So when we create a new database, it needs to get a new secret for accessing. And then if we, for example, restore a database, we also need to be able to refetch the secret and to reuse it for accessing the backup of the database. And maybe we even have to allow people access to our systems, and also they would need access to the secrets for that. The next question is the lifetime of secrets. Immortal secrets are convenient. So you create a secret one time and then use it until you switch off the system that you're using. Really easy, everyone understands it. You know, I have the secret and then you can use it. But this usually has the problem, there is no mechanism for handling secret changes when they are necessary. For example, if you know the secret has been leaked, how would you handle that? A solution for that could be short-lived secrets. They are more secure in the sense that you already have a mechanism to change them easily, and in many cases you can design them in the way that if a secret is leaked, you can be pretty sure that the impact is at least not too big, because you know it will not be valid for too long. And maybe you can even easily switch it off. Next thing, gossip of secrets. So especially if you have immortal secrets and you have people in need of the knowledge of these secrets, for example, for configuring services, for accessing resources, then you have to distribute them. And then other people also know about them. But you also distribute them over configuration files for parts of your system. And the questions that arise then, who knows which secret? Where are these secrets stored? If I want to change them, whom do I have to inform that there has been a change? Where do I have to make the change in the configuration files so that all my systems can work properly with the new secret? And last but not least, pretty simple one, but how to securely store and handle secrets. How secure is my secret store? How secure is transport and the chain from the store to the point of use of the secret? Classical approaches to secret management, the most well-known and the one that nobody wants, sticky notes on the monitor or on the wall, pretty convenient for all users, but security, not so much. The next step would be individual key stores, for example, a key path file. But then you still have the problem how to share the secrets. How can we use them, for example, in system setup, system configuration? A solution for that could be Ansible Vault files that are also shared together with your code. It's a way of storing your secrets in an encrypted file that you can store together with your code in your source code management system. Then you know where the point of truth is. You can use it, for example, also when compiling or in your CI/CD pipeline, but you still would have the problem how to access that secure file, because at least that needs another secret. And one option to store that, at least for CI/CD systems, would be in the secret stores of a CI/CD system. An example for that would be GitLab CI secrets. With the last two together, you can already build quite convenient automated CI/CD infrastructures that handle secrets at least reasonably well and reasonably secure. But we decided we want to get one step further, and the solution that we found for that was HashiCorp Vault. So HashiCorp Vault has the advantage that it is one central store, single point of truth, so we know where the actual current secret is that we need. It supports secure generation, storage, and distribution of secrets, so you have different ways of distributing secrets, but they are all secure, so encrypted. You can have support for multiple authentication methods, so you can be sure that both users and systems are authorized to access your secrets before you let them get to the secrets. It supports dynamic secrets, so for example, you can say if someone needs access to a database, you create an individual secret for that person with a lifetime of, say, 30 minutes, which may be enough to investigate a problem. And after that time, the secret will get invalid. So even if the secret is on a sticky note and someone reads it a week later, he cannot do anything with the secret. Another kind of bonus is that the store in its encrypted status needs unsealing with multiple keys, or at least you can configure that. So in case of disaster recovery, you can say we have, for example, 10 keys, and we need at least 5 of them to unlock the store, so to actually get access to the secrets, to the secret file. And that allows you to have reasonable security, because you can distribute the keys, but you don't need all 10 keys at the same time, but you can say, okay, for example, we have 10 DevOps guys, each one knows one of the secrets. I only need to get 5 in one place to actually get back to the secret store. And a bonus for us, because we are using Kubernetes, HashiCorp Vault can also act as a public key infrastructure. So for us, it can generate all the TLS certificates that we need to ensure encrypted communication or secure communication between the components of our Kubernetes system. So that's the introduction, that's the background for how and why we want to use HashiCorp Vault. And with that, I will hand over to the demo and to my colleague Thomas, who will guide you through that.
Thank you. Okay, so we decided to skip another part of 40 presentation slides, just showing you configuration. Instead, hopefully it will go well, go directly into the Vault server and we'll present how we can use it. And therefore, we have prepared a setup of a Spring Boot application that we want to deploy in a Kubernetes cluster. In this case, we are using Minikube for local installation. And we have HashiCorp Vault and a Postgres database, both running as local Docker containers. Our target will be to get our secrets from HashiCorp Vault in order to access the database. Okay. So I'm using here the Vault command line interface. And normally you would perform now user authentication method, as Tilman mentioned. I'm just using now the root token that you get provided if you initialize the Vault server. You should normally not use this in the production, but to keep it simple, I will make use of it. And we will start with a first secret engine that is available at the path secret. It's a key value secret store. And there we are able to store at the path a specific data set of key value pairs. So I have prepared here an example with a welcome message for the microXchg. So here you see we just get a key, for instance header, with a value hello microXchg. And in that way we can of course also store our required database secrets. So we go here and then we get our secure admin password and also the application user password. Okay, so now we have stored our secrets in our Vault server, centrally managed. The question is, how do we get them into our application? And for that, we will need an authentication method to prove that our application is allowed to access the secrets. Therefore, we will use the Kubernetes authentication method that is provided by Vault. And it will use the service account token that is attached to the pod. It will be provided to Vault. And Vault will perform against the Kubernetes token reviewer API a check if this token is still valid, and will also retrieve metadata to check for specific criteria. So I have prepared this authentication method. It's available at the path Kubernetes Minikube. You see it's a type of Kubernetes. And what I also did is to define the Kubernetes API endpoint, so Vault knows where to contact Kubernetes, and also the certificate authorities in order to check it is connected to the correct endpoint. And additionally, you need to provide a service account for Vault because it needs access to the Kubernetes token reviewer API. So you have there a cluster role binding. And we are still missing some part. We need a role definition. And I prepared here the inventory app. No. Right. We're coming closer. Okay. So here you see we have criteria defined that must be fulfilled. The account name must be inventory or Go query account, and the namespace must be microXchg. And only if these criteria are matching in the service account, then Vault will provide access with the inventory app policy. You see also here we have a period time defined of 30 minutes, and this will force our application to perform a renew of the token within 30 minutes. Otherwise, the token will be revoked. So we make sure everything is cleaned up if it is no longer required. So let's check the policy. As you see, everything that we are actually accessing in Vault is on a path basis. So it's pretty similar like a file system, and you would also manage the privileges in that manner. So let me check policy, read, and then the inventory app. And here, for example, you can see we have a path-defined secret inventory app with the allowed capabilities. The operations read and list could also be update or delete. So that's how we take control of. So now we have our authentication in place and we have the secret stored, okay? The next part we need is to retrieve our secrets in the application. And I mentioned we have a Spring Boot application. You would normally have an application YAML where you define all your application properties. And you would also define here via an environment injection the data source properties, maybe stored in a Kubernetes config map. What we will do now is we will leave that there out, and we will make use of the Spring Cloud Vault package that will directly retrieve the credentials from Vault. But therefore, we need to add an additional configuration file, the bootstrap YAML. And this will be executed right before the application starts, because we need our credentials before the database connections are initialized, right? So we have here a Vault element defined with all the required parameters. You see the Vault URL, right? You see just a placeholder, sorry. We have different environments. The authentication method, Kubernetes, we want to use. And then we define the path where this method is available, Kubernetes Minikube, and the role, inventory app. You remember I showed you before. And then we enable a generic secret engine. And this is just the one we also used in the command line interface right before. And there we define a default context. What you need to know is that Spring Cloud Vault will query the credentials as a specific path. So I have additionally stored the secrets here at the path inventory app and Minikube. Minikube is, for me, the Spring profile name. And there you can see we are getting the Spring property names provided with the credentials. So Spring Cloud Vault will query this data set, inject it to the application, and can then connect to the database. So, right, then we have everything in place and can actually deploy our application. So keep fingers crossed. We are now building a jar file, and then we will create the Docker image within Minikube and trigger a redeployment. Okay, so here you can see we have running the inventory application. It is not ready right now. Still starting. Now it's ready. And I can now use the REST API to query an inventory item from my application. So here we get an item from our database. Seems our connection is working. So let's also check additionally the log file, because as developers need to test something, they would like to add some debug action that accidentally might also leak some credentials. So we will use this to check that our application user has been used. And you can see that's the one we retrieved from this Vault server. Okay, everything is in place. So that's pretty nice. We have now our secrets in our Spring Boot application available, but we might also need it in our infrastructure. So therefore, I will shortly show you Terraform. And in Terraform, you can also integrate Vault. Of course, it's an HashiCorp product. Would be bad. And there we have data elements that we can define for Vault generic secret. And here is a path that we define. So Terraform will query Vault to retrieve the secret, and then you can access the secret with this data object. And you see I have here a provider definition to access the database, and I'm just reusing the secret from Vault. I could also use it to create resources like this application user and make use of the username and password that is stored in our Vault server. Okay. So this is very helpful, but would our debug action now still hit production we have a problem because we have a static secret. We would need to change all the infrastructure if we would need to rotate the password. As Tilman mentioned, we want to use the dynamic secret. So that's really moving it to a layer, to a next layer. Let's say we are using secrets as a service on demand, and they are only existing as long as they are required. So what we need to make use of it, we will now use a special secrets engine that is available at the path DB of type database. And there we have defined our database connection because Vault needs to contact our database. So you see the connection URL inside, and we are also using a specific user for Vault that is allowed to create database users in our database. We are also defining the kind of database we are using. In this case, it's Postgres, and the allowed roles that can make use of this connection. The inventory app role and the inventory read role I also prepared. So let's look into the app role. You see we have here creation statements. These are our create user statements that Vault will use to create the dynamic database users. And we also using properties like name and password because they will be generated by Vault on demand. We also have an expiration because in Postgres you can define an expiry for your database users. Additionally, you see here a default time to live, and that again will force our application to renew the lease for this database credential every 5 minutes. Otherwise, the database user will be destroyed. So again, we make sure everything will be cleaned up. And of course, I could now also use this to get some database credentials for me. Inventory app role, and there you see we get a username and a password on demand. And for the human part, you could make use of this maximum time to live, and you could define it to 1 hour, and then the database user would only be available for 1 hour. So you can provide credentials on demand for your team, for your developers, operation engineers, or support engineers to get their job done, and can be pretty sure after 1 hour they will not have access anymore to the database. And I think that's really awesome. Right, but we also want to use this in our application. So therefore, we are now disabling the generic engine, and we want to use the database. So we have the path to our secret engine defined and the role, the inventory app role, and we define the properties where the database user should be injected. Additionally, you should know I have Flyway activated here, and we will reuse for Flyway the application user. And something more we need to take care of, because with Flyway we will create database objects in the database, like sequences or tables. We must make sure that they are not owned by the dynamic database user. Otherwise, we cannot delete this user. And therefore, we're using this set role pattern to make sure the objects are owned by a generic, in this case, the app user's role. Okay. So that should be everything we need. Let's again deploy our application. We should see now that the pod gets terminated. So now I cannot query any more inventory items. The application gets ready again, and I can access the database. Okay. Let's check the log file. And there we see our dynamic database user is in place, and our application will now start with this dynamic database user that is only existing as long as our application is running, and it will be revoked when the application is shut down. And if we have a leak in production with our nice logging action, then we could just restart the pods, and the leak is resolved. Your operations team would be happy. Okay. But you may also ask, how can I use this in an application that is not a Spring application or that is not able to use Spring Cloud Vault? And therefore, we make use of another pattern. We will deploy a Go application. Accidentally, I also wanted to try out Go. And we will add some additional containers. And our target will be that the Go application is not aware of it is using or integrated in Vault. So we have the Vault agent that will perform the authentication, and we have console template that will retrieve the secrets. And then we provide a rendered configuration file for our Go application that will just use the secrets and access the database. Again, we make use, of course, of the service account pattern with this Kubernetes Authentication Method. So therefore, I will move to Terraform again. Oh my God. Because I wanted to try the Terraform Kubernetes provider. And there I'm creating a Kubernetes deployment. So from the configuration perspective, it's very similar to the YAML file. And there we have the Vault agent defined. It is just using the Vault binary. And it is started with the agent flag. Additionally, we need to define this agent configuration file. And there we define it should perform an automatic authentication with Kubernetes at the path Kubernetes Minikube we already used before, and the role we have used before, the inventory app. And additionally, we have a Vault token file defined here that will written actually to a file so that we can use it in the next step. And the next step is the console template container. This is also a tool provided by HashiCorp, and it will enable you to render a template file with credentials from Vault. So we provide a configuration file here where we define the template content. Actually, you can see it will be in the end a JSON file. And we are using a template language here to access the secret from Vault. Available at our creds path we used before with the inventory app role. Additionally, we can also provide parameters we need for host and port. And here is our dynamic database user, actually. Again, injected, and the rendered file will be provided here at this destination. Good. So you also see we need some volumes mounted to get the Vault token managed and also the console template configuration file, and of course, actually our Go query application config. So console template will render this configuration file and store it, and then our Go query application can start and make use of this configuration file and is actually not aware of that it is Vault integrated. Okay, so let's see if this works. So I'm just scaling a deployment I have prepared before. You see, actually, we have here some errors happening. That's just because I did not take care of the sequence. Normally, we have at first the token required, then the rendered configuration file with the credentials, and then the application. In this case, the containers are just restarting until everything is available. And hopefully, we will see soon 3 ready containers, right? And now we can query our Go application to get the actual database users in our database. So you see we have the admin and the app user, our static ones, and additionally 2 dynamic ones. So these have been created with our Go and inventory app. And of course you want to see the dynamic behavior, right? So let's start more replicas. Actually, I can just use this one. Let's scale to 10 replicas and see what's happening. You see more and more containers are getting created. And hopefully, we will also soon see more database users that are popping up. Okay, and here you see they are getting created on demand. And this means each pod that is running here has its own unique database user in place. Okay. One more thing to show. Tilman mentioned we also have an auditing in place. Everything that is accessed in Vault will be stored in or logged in an audit log. And I prepared an Elasticsearch, Kibana, and Logstash configuration to make this visible. Hopefully this will also work. So here we can see now all the requests that we have done so far in the demo. So we can also look for our welcome message we did in the beginning. And you see it is here when we executed it. And you get properties visible like the identity that has been used, the policies that has been used, also the operations that have been executed, update, read, and the path that has been used. And with all these information, of course, we can also analyze the usage of our secrets. And maybe that's the part how you can convince your management. We can show all these, we can get insights of how our secrets are used, how many requests have been done in the last hour, how many errors have been occurred, and how many Kubernetes logins have been done. You also see the root access we have done with the root token. And we can see when this has happened. You can see all the operations that have been used. Here you can see the identities that have retrieved secrets on the secret path and what secrets they have requested. The welcome, DB admin, whatever. I could also, of course, say, show me only the inventory app. Then we see actually everything the inventory app has accessed from our vault. So here you see also the database credentials that we have requested and also from what identity this has been done. You see the root token from the beginning. And with the metadata, we can also see in what Kubernetes namespace this has been triggered. So this gives us very much insights of the usage of the secrets, and we are also able to establish monitoring for it, and you could identify malicious behavior and trigger alerts. Okay. So let's also check if everything gets cleaned up. I'm scaling down the replicas. You see the pods are getting terminated, and in the same time you see all the database users are cleaned up, so they are no longer usable. Okay. So let's wrap up, and instead of using again some PowerPoint, I have chosen to summarize for you the points here. So we have, at first, of course, you should try to make use of these dynamic secrets with the limited lifetime. They are very helpful. Also, just in the kind of using them for human interaction with the database user we have mentioned before. And there are pretty more secret engines you can use in Vault. This was just one example with the database. There is an SSH engine available for SSH keys to connect to a server, for PKI to generate, for instance, client keys with a short lifetime, and also AWS credentials you could generate. I recommend to start with a local Docker container. I'm also used here just to understand the concepts of Vault, play around, and then try to find out how you can make use of it in your company. Check the official Vault website. There are really many guidelines available. Also, this example I have shown with this console template in Vault Agent is something documented on the Vault website. Of course, this is also important. You have a secure store for your secrets, but also make sure all the communication channels you have in place are using TLS. It would be bad if they get transmitted unencrypted. This can happen faster as you expect. And one more thing, maybe, I don't know if everything knows it, but if you use Vault within Terraform, take care of your state file and plan file, because your secrets will be unencrypted there. So always encrypt these files and make sure they are not accessible from anyone. Use these database roles I have mentioned before to manage the privileges outside of Vault for your dynamic users, and use this set role pattern in Flyway to fix this ownership of the database objects that are getting created. Okay, and last but not least, have of course fun to start using Vault. And yeah, I see we are pretty good in time, so I could actually, it's the last session, right? Let's have some fun. I will start now an monitoring server. Pretty simple one. And this will now get triggered, hopefully, from our Logstash client to perform a shell script for an alert, because we don't want to use the root token in production, right? microXchg root. Okay. So let me check. Sound is online.
Hey, didn't I tell you? Don't use the root token. Dear audience, thanks for listening and have a great evening. We hope you enjoyed the show.
Okay. Thank you.
Any questions?
Hello, thanks for the speech. So when I think about the Vault, I feel like it's big commitment, but can we start like something very small and then implementing over time? So how would you recommend starting with Vault? this sense?
We have actually a department that has used the Vault in production earlier than we, and I think they did a good approach. They used a Vault instance, a single instance, just storing all the secrets and requesting them on build time and injecting them for the deployments, right? So this, I think, is an easy approach to start with getting familiar with Vault, because these stuff we have seen with these dynamic credentials are not easily to handle, and you have to take care of a lot of stuff. And also you need a high available Vault instance. We don't run this actually in production. It is in a pilot phase, and we are planning in the next month to get our projects that we can convince start using this, and then we want to see how this works. Yeah, actually, we have running our HA setup in the sandbox cluster, so to say, where we play around and also try to integrate it in our Kubernetes next version. Okay.
Yeah, thanks for the talk. Did you notice any performance degradation from using this? Because I mean, you are trying to read information over the network and stuff like that. So when you moved to Vault, was there a degradation in performance for your services?
Right. For the runtime part, we can actually not provide any numbers. But what you should be aware of is that Vault has only one running active instance, and the other ones you are spinning up in the cluster are only standbys. Yeah? So this means all the traffic will go to this one instance, and there will be some latency. So, but also, I mean, I think it was Hashimoto or who called it, for the security, you should just take into account some delay. Yeah? And I'm pretty excited to see how it will scale up with our applications that we will enable in the future. Yeah.
And the other thing, the question is, where do you use it? I mean, for example, if you say you use it in a CI/CD pipeline, then you will be pretty sure be able to handle a short delay. If you would use it dynamic secret for every request, most probably that would be, on the one hand, the most secure approach, but on the other hand, kind of overkill and would definitely be a latency issue. But if you use it, for example, like this, like in this demo, so every instance of your service you spin up gets its own dynamic secret, and when it's destroyed, the secret will also be destroyed, then you will have no delay during actual application use, only during spin up of the application. And I guess that should be feasible for almost any use case.
Thanks.
Question here?
Sorry. I didn't understand how the application is allowed to read from the Vault addresses. Is it because they're all part of the same Kubernetes cluster, or? I understood the addressing, but how come it's allowed to?
In both cases?
In either of them. The second one, perhaps.
So maybe just let's look here into in the overview. We have this service account that we can attach to a pod, and this service account has specific criteria defined, like a name or a namespace, and this will be checked by Vault in order to attach a specific policy. Yeah. So this means if you're coming from another namespace, you will not be allowed to get access to the credentials. Okay.
Okay, thank you very much, Thomas and Tilman. And I'm really afraid this seems to conclude this year's microXchg already. And on behalf of all the organizers and the helpers and exhibitors and everyone, I would like to say thank you very much for your attendance, and we really had a great time. I hope it's the same for you. And now the only thing I can say is get home safely and come back next year.